All right, here we go. The empirical rule. This is found in the end of section 3.2. I'm sorry, 3.3, excuse me. The empirical rule basically says that if you look at a set of data, and the data is bell-shaped, and what we mean by bell-shaped is that if we could draw a curve onto the graphical display, you see how it kind of gives me a bell-shaped curve. We've talked about skewness. We talked about being skewed out to the left. We talked about being skewed out to the right. And what we're looking at here is going to be a bell-shaped curve. It's also called a normal curve. In this case here with the bell-shaped curve, what we find out is that we can actually get a measurement of 68% of our data. And 68% of our data can be found one standard deviation away either below the mean or above the mean. Now, key thing to remember is that the problem we just did a minute ago, number 21, the standard deviation was like 100 and something. And on number 7, the standard deviation was like 12 or something like that. Standard deviation is different for every set of numbers because it's the average distance a number in the set is from the mean. It's really kind of confusing, but basically it just measures how spread out the data is. So in this case here, our data is not very spread out. 4.2 is not too bad, so this data doesn't really vary too badly. So this is a generic picture. This is not a picture of this data set. This is a generic picture of what we use for the empirical rule. So what I want to do is I've identified right here that my mean or my average is 26.8. So that's this number right here. So I'm just going to go ahead and write 26.8, and that's my x bar. This number right here is going to be my standard deviation, one standard deviation below my mean. So in that case there, it's 26.8 minus, well, what is my standard deviation? Oh, there we go, 4.2. So now I come down minus 4.2. This guy right here is going to be one, oops, my bad. This guy right here is one standard deviation above. So that means I'm going to take my 26.8 and I'm going to add 4.2 to it. So what happens here is that when I put those together, 26.8 plus 4.2, I get 31. And when I take 26.8 minus 4.2, I get 22.6. So what that means right this second is that 68% of the data in my set, or 68, in this case right here, we're looking at the average U.S. yearly per capita consumption of citrus fruit. Citrus fruit is 26.8 pounds. What we're saying is that 68% of Americans consume between 22.6 and 31 pounds of citrus fruit per year. So right now we can actually answer the question, because what the question says, what percentage of Americans would you expect to consume more than 31 pounds of citrus fruit per year? Well, let's just go ahead and answer the question. If I wanted more than 31, okay, so let me get a different color here so I don't mess things up. So I'm looking for something that's bigger than, oops, that's bigger than this number right here. Well, let's think about this for a second. If I split this in half right there, that's 50%. So if I take that 68 and I divide it by 2, so I take the 68 and I divide it by 2, when I do that, I get 34. That means that I have 34% right here that I have to take away from the 55, or the 50, excuse me. So this right here is 34%. So what's left over out here is going to be my total of 50%, or the top half, minus the 34, which is 50 minus 34, 16%. So at that point, what that leaves me with is 16% of Americans consume more than 31 pounds of citrus fruit, excuse me. All right, so that's how we answer the question. But let's take this question one step further. So let me hit pause for a second. So let's finish up the discussion. So the discussion was that if right now we know that 68% of Americans, that means between 22.6 and 31, eat 22.6 and 31 pounds of citrus fruit. So now let's go find out what 95% would be. Well, the 95 rule is that right here, if we come on down, we're going to take 2 standard deviations below. So the 95 rule says that I'm going to take the mean, which is 26.8, but this time I'm going to subtract 2 standard deviations. So I'm going to take 2 times my standard deviations. And then I'm going to go above. And when I go above, I'm going to take my 26.8, but I'm going to add 2 standard deviations to it. So when I do that, what I want you to notice is when I do the above, I get 26.8 plus 2 times 4.2. My graphing calculator knows order of operations, and it tells me that I have 35.2. And when I do the below, a quick little trick right here to pull that previous statement up is I can press second, enter, and it pulls my previous statement up, which now I can go across and I can edit it and change that plus sign. So see how I moved over to the plus sign, change it to a minus sign and press enter, and 18.4. So what this is saying is it's saying now at this point that 95% of Americans eat between 18.4 and 35.2 pounds of citrus fruit. All right, I can go one step further, and I can go all the way up to 99.7. So I can kind of figure out, what is the bottom, the minimum, and pretty much the maximum of the set. Now notice it's 99.7. There's still something out there beyond it, but we're talking about 3/10 of the population. So when I do this, let's change colors one more time, and we'll go to blue this time. When I do the 97 percentile, I come down here and I'm going to say 26.8 minus 3 times 4.2, and I'm going to take 26.8 plus 3 times the standard deviation because I'm taking 3 standard deviations. So that gives me 26.8 plus 3 times 4.2. Press enter. So that gives me an upper of 39. Oops, sorry about that. Oops, times 4.2. That gives me an upper of 39.4. And remember, I can press second, enter to the previous up, move over on top of that plus sign, and make it a minus. Oops, sorry. And move on over there. Make that a minus, and press enter, and I get 14.2. So that means that 99.7% of Americans eat between 14.2 and 39.4 pounds of citrus fruit. So you can break this down however you want. If you want to say the bottom half, if you want to say, what percentage eats less than 18.4. So if 18.4 represents 95% of the population, so then that means that if I have 95% of the population out of 100, that leaves me 5%. That means that over here is actually 2.5% left over. And then out here is 2.5%. So I don't get too much into that with the tricky questions. The main thing is I wanted to go more in depth about how you can read it, what it means. So if you have more questions, just go ahead and address them with me. That's number 41. That's the last video.